So the next command we're going to look at uses as an example a rotating printer. So that looks like this, I hope. There we go. So we've got a rotating drum with a print head on it. It has a fixed circumference, of course, because it's a mechanical drum, and our desire is, what we want to do is be able to print at different pitches, different lengths. So if we had no ability to do that, it would always only print at whatever the circumference of the drum is. In fact, old style printing machines were like that. You basically put on different diameter foils, they call them, which then would give you the length of the print. But this technique that we're using with the command you'll see in a minute allows you to modulate the speed of it to make it print at different pitches with the same circumference of drum on there. It says at the bottom there, cutter has the same action, so if you had a blade there instead of a print head, it would be the same thing. And there are a lot of flying cutters like that, which just have a blade, or even sometimes two blades, one at the top and one at the bottom, to do cutting. So it's the same principle. The command for this is FlexLink, and this is a really new command. I say really new, more than 5 years old, probably less than 10 years old. So it's in the last decade this was produced. And because of that, it does all the work for us. It's not like a move link. We don't have to do all of that calculation in ourselves. There's a lot of parameters on there, but all of the maths is taken care of in the command itself. So we end up with, effectively, there's what we call a base distance there and an excitation distance. And if you add those two together, that gives you the total movement on the slave. Okay? So the slave will do the sum of those two. And in the diagram you can see that the base distance is the yellow bit, that's constant, and the excitation distance is this acceleration that happens. And again, if you think of the area under the curve being the distance moved, then the total of those two, the yellow and the grey areas, are the total distance moved on the slave axis. Then we have the link distance, so that's the distance on the master, similar to the move link. And then we have some things called base in, base out, exac and xdec, and they cover the areas shown in these boxes here. So the base in is this yellow area before it starts to accelerate, and the base out is likewise on the other side. The excitation acceleration is the ramp here, and the deceleration is the ramp here. They have an S profile, so they're always smooth accelerations and decelerations as well. And then of course lastly we have our good old master axis number on there. If we take our example again of our drum there, so we want to synchronize that at 1-to-1 when the print head or the cutter is touching the material, it needs to be running at the same speed. And the drum circumference is 400 in my example, and we want to say print it at 325. Okay, so we need to subtract about 75 millimeters from each movement, if you like. So we've got to accelerate the drum when it's out of contact with the material, so it pushes ahead by 75 millimeters to take up that difference. And there's a picture of the motion. And the program is fairly simple. You set up all of those parameters and then you run the FlexLink. So I'll probably just need to walk you through the parameters a little bit. So the first one, base distance, that's 325. That is the distance of the actual print we want, as is the link distance. So base distance and link distance are the same, 325. That's our print pitch. Then the excitation distance, which is the extra bit over the top there, that is simply the circumference minus the base distance. So that gives us our 75. So those three parameters really describe exactly the motion distances we're going to deal with. And then the other bits, the base in, base out, excitation, etc., those are percentages. So I said the command itself does a lot of the maths. You just give it the percentage of base in you want and the percentage of excitation, acceleration you want. Now I've turned these into degrees because I'm thinking of this as a rotating device. So I've actually done a 90 degree divided by 360 times 100 gives me my degrees as a percentage. Yeah, so I've just changed that to degrees just so it's easier to think of in some ways. So we've got 90 degrees of in and out, and we've got about 30 degrees of acceleration and deceleration there. And then we just run the FlexLink, and that's it. It just does that. So when we turn that into an actual program, the actual bit that does the FlexLink is this repeat loop here, repeat until in6 is off. So it just goes around. It does recalculate everything here. That's probably unnecessary. You could make this more efficient if say the base in, base out, etc. They're not really going to change. So you could have them set up once before the loop and only change the pitch, for example. Or if it's a fixed thing, you could take all of that outside the loop and only do the FlexLink in the loop. Yeah, it basically does it all for you. So you need to initialize the axes. So down here we're doing initialization. So Reza will be pleased to see we've got the ret disk set up for both axes, so we don't fall over ourselves like we did with the MoveLink. And then the homing is simply to find bottom dead center, so that we can calibrate the rotating drum. So it does that with a datum 3. It's looking for a datum sensor, and then does a move abs to position it at bottom dead center, and then defines that as a 0. And that's it, really. It's much more simple than, for a programmer, much more simple than MoveLink. And in fact, this could take the place of MoveLink in a lot of places. If you remove the base distance, then effectively you end up with a MoveLink. So if I take away the base distance here, so this all becomes 0, then I've got a MoveLink. So it could replace a MoveLink in some circumstances. That kind of reminds me of something about MoveLink. Is it isn't possible with MoveLink to do what that does. You cannot have a MoveLink that starts at a ratio that's already non-zero. MoveLinks always start and stop at 0 ratio. So the FlexLink gives you the ability to start from an already moving axis and then add on the extra movement. Simple enough?
Yeah.
Good. So
a rotary cutter, which is very common. There is a graphic or an import from an OBJ file that was done for this. Again, this one's a bit simpler, and we define the cutter axis and we define the conveyor axis, and we can test it again based on the scaling that we want. So in this case, the conveyor is a linear axis, and the rotary knife or the rotary cutter is of course a rotary axis, and we define the distances and movement for that. Once that is done, we link the axes, in this case just 0 and 1, and we have a program here that will run our FlexLink command. So we run that program and run the cutter, and this should make a cut of this length here, which is the markings on the conveyor. And so we can use this tool to help develop our program, and we can do things like speed up the conveyor with some program variables that might be on the HMI, and we can also change cut lengths. We want to add that to cut at every other cut. We can do that, and we can simulate that. So a very good tool for developing programs and debugging and seeing if things are moving as you would expect.